This presentation is the first of 3 presentations on calculating and interpreting a z-test. We will learn in this first presentation why a z-test is important for statistical inference. In the second presentation, we will learn how to use the formula for the z-test properly. And in the final presentation, we will learn how to interpret the results of the z-test. A z-test is based on the concept of z-scores, which we learned about in a previous presentation. The z-score is also called a standardized score, in that it's based on the standard deviation. Z-scores allow us to view which observations are more deviant than others. Most observations are relatively close to a z-score of 0. The ones that are either greater than 2 or less than -2 are among the 5% of observations that are in those ranges of z-scores. In other words, 95% of all observations are within the band of -2 to +2 standard deviation units from the mean value. The z-test expands on this principle of deviance to allow us to test a hypothesis about a sample mean value and its relation to a population mean value, based upon the population standard deviation. As you can see, the formula involves 3 parts. X bar is the mean value of a sample variable that we call x. Mu is a population mean value from which sample variable x was drawn. Theta is a population standard deviation value from which sample variable x was drawn. In order to use the z-test, we need to know what the population mean and standard deviation statistics are. Since we generally do not have access to population statistics, and instead are given samples to work with, the z-test has somewhat limited applicability. Nevertheless, it's a good starting point in inferential statistics, generalizing from our sample to a larger population. Thus, the first hypotheses we will consider for inferential statistical testing are based on how different our sample mean is from an overall population mean. In the next presentation, we will move toward creating a testable hypothesis and calculating the z-test result of the hypothesis test.